Hello, welcome to my video titled Introduction to VLANs. The purpose of this video is going to be to explain a broadcast domain. Once you know what a broadcast domain is, we can learn about VLANs, why we use VLANs, and how VLANs affect our IP addressing. In a broadcast domain, all devices are part of the same local area network and share a common layer 2 network segment. A switch is going to flood a broadcast traffic out all ports except the port that received the broadcast. As we can see here, a broadcast originated by the PC is going to go to the switch and the switch will flood it out all ports. All devices within this broadcast domain, they can reach each other without having to go through the router. Now the router is going to stop the broadcast. It'll receive it, process the frame, but it will not forward that broadcast out to other devices. So why VLANs? Well, one reason for VLANs is to control our broadcast domain size. In this example, we see a switch with 384 switch ports. Most organizations are going to want to keep that down to Class C addressing space of 254 hosts on a network. Another reason we want to control our broadcast domains is we want to keep our users from reaching other devices. In this example, we see some security cameras on the same network as our end users. We don't want them to be able to reach the end users without going through a router, because a router gives us the ability to permit or deny traffic based on the IP address and protocol using access control lists. Traffic through the PCs does not go through the router. So as we look right here, traffic on these PCs can go through the switch and directly connect to these cameras without any way of filtering. One solution would be to separate the LANs by adding a switch. So in this example, we've added another switch to our IDF closet, and we've put those two cameras on a separate switch. Well, now this switch needs a connection to the router, so now we have two network segments, so we've separated it, but it gives us much more hardware to deal with. Routers can also implement quality of service to prioritize the voice and video over this, but we still have this hardware issue. So adding this additional switch means we have to add additional devices, requires more maintenance, more network management, more cabling, and of course, more router interfaces. What if I need to separate all of these? Users, cameras, wireless devices, badge readers. What if I'm separating by department? HR, engineering, sales. I can be getting a lot of VLANs, and we can run into a situation like this, where I have one router connected to 6 switches to isolate 6 separate networks within the same physical region. We can solve the problem of needing to separate traffic without buying additional hardware by creating VLANs. VLANs create a logical layer 2 separation within a switch. A switch will only forward traffic out the ports that are on the same VLAN as the receiving port, and traffic from hosts on VLAN 10 must go through the router to reach the cameras on the VLAN. So let's take a look at how this actually works. As you can see here, I've got one switch, and we've got 3 ports on VLAN 20, and 1, 2, 3, 4, 5 ports on VLAN 10. And the switch will not send any traffic that comes in on VLAN 10 out any ports on VLAN 20. So in this example, we're showing a broadcast both from the PC here and the camera, and it's only going to send that traffic out ports that are on the same VLAN as the receiving port. Configuring a VLAN is fairly simple. The first thing you have to do is you need to create the VLAN on the switch, and then you'll assign the switch ports to the VLAN. And we'll get into that during the lab portion of this exercise. Okay, now let's take a look at how VLANs work in a lab environment. Right here we have 2 logically identical networks. The one on the left uses 2 switches, and the only difference is the one on the right uses 1 switch and takes advantage of VLANs. If we look on the left, we can see that PC1, or PC2 and 3 for that matter, can only send traffic to the cameras if they go through the router first. And hopefully the administrator on the router has an ACL on there isolating these cameras from the PCs. Now the one on the right does the same thing, except we only have 1 switch. We have gig 01, fast Ethernet 0, 1, 2, and 3, all for VLAN 10. And we have gig 02, fast Ethernet 11 and 12 assigned VLAN 20. But for right now, we have not configured the VLAN on the switches, so let's take a look at how this works without the VLAN. So I've turned on simulation mode, and I've already edited the filters to include only ARP and ICMP. So let's go into PC3, and I'll go into my command line, and let's see what happens when I try to ping 192.168.20.12. And I've created my ICMP packet here, and it's not going to go anywhere because it doesn't know the MAC address, so it can't send it. But I've also got this ARP request that's going to go through. And what I'm doing is PC3 is sending an ARP request to try to find its default gateway. But notice that ARP request got flooded out all switch ports. That tells me that PC3 can connect to camera 1 and 2 through the switch. The only reason it's going through the router is because the IP address is different, and PC knows if it needs to get to another network, it needs to send it to this interface of that router. And the solution to that for the PC would just be change your IP address, and it's essentially going to be able to connect to camera 1 and camera 2 without even going through the router. So we want to put that logical barrier there in our switch, preventing PC3 from connecting to cameras 1 and 2. So I'm going to go ahead and go back to real-time mode and let this finish. I'll click fast forward to make sure I've sped that up. And let's go in here and configure our VLANs. So I'm going to go into the switch and go to the config tab. And remember, the first thing we have to do is we have to create the VLAN. So I'll go ahead here and create VLAN 10. I'll give it a name of users. And I will add that. And then I'll create VLAN 20 and its name will be cameras. And I'll add that VLAN. Now the next thing I need to do is I need to go ahead and assign all 4 switch ports to that VLAN. So I'll start at Fast Ethernet 01, I'll apply it to VLAN 10, 02, VLAN 10, 03, VLAN 10. And I can't forget about my gigabit uplink, so I'll come down here to gigabit 01 and put that in VLAN 10. Now I need to do VLAN 20, so I'll take gigabit 02 and I'll go ahead and put that in VLAN 20. And I'll go up to 11 and put 11 and 20, and then last but not least we'll put port 12 in VLAN 20. So now we've got our switch and all the VLANs assigned. I'm going to go ahead and double check that. I'm going to go into the command line and I'll type end to get back to privileged exec mode. Then I can type show VLAN. Let me widen this out so the output is better. And let's see what I have. And I have, oh, I misspelled my VLAN name, USERS, but that's okay. But I did indeed create all 4 switch ports on VLAN 10, and on VLAN 20 I have the proper switch ports assigned there. So now let's take a look at this. We'll try from PC1. So PC1's got the same thing going on, but I just want to start with the device with a clear ARP table. Now when I send this ping out, 192.168.20.12, PC1 knows to get to another network it has to send the packet to the MAC address of its default gateway. So it's going to send that broadcast ARP frame out. And let me turn simulation mode again so we can watch that. And back to PC1, and I'll hit enter. And there's my ARP broadcast in green. Destination MAC address of all Fs. And if I hit the next button, it's going to send it to the switch. Now the switch is only going to forward Ethernet frames only to ports on that same VLAN. So now these 2 cameras won't be able to talk to that PC. The cameras can really only talk to the router interface. And if we put access control lists on the router, then we can limit which devices can talk to what. But as you can see, I sent a copy of it to the router and to the 2 other PCs, but I did not send copies of that ARP broadcast to the other switches. Now that I have the MAC address for my gateway, I can send that ICMP request up to the router, and now the router is going to forward it to the MAC address of camera 2. Or is that an ARP request actually? Let's look at that. It has the Ethernet frame, but it looks like the switch doesn't have the MAC address in its MAC address table yet, so it sent it out both ports. That's one thing switches do. If they receive a frame to a MAC address that's not in its MAC address table, it will flood it that first time. But what's going to happen now is it's going to send it back to the switch. The switch is going to learn that MAC address, and the next ICMP packet will actually go unicast through the switch, and we're no longer allowed to send packets or Ethernet frames from one VLAN to another. It has to go through the router, back to the switch, And now that the switch knows the MAC address for camera 2 is on port 012, it doesn't send a copy out all ports on VLAN 20. So anyway, I hope this explains VLANs to you. I hope you found this video helpful. If you enjoyed this video, please remember to like and subscribe, and thanks for watching.